Hello everyone. So in this video, we will be discussing compound interest, still under the interest and money time relationships. So last time, from the last session, we have discussed simple interest, the two types of simple interest. And now we will be discussing compound interest and how are we going to solve some problems related to compound interest. So the interest earned is computed every end of each interest period or the compounding period, and the interest earned for that period is added to the principal. So this is what the cash flow looks like for the compound interest. And we still have for the formula of the future worth, we have this formula where f is equivalent to p multiplied by 1 plus I raised to n, where p is the present worth or the principal or the present money, and I is the effective interest per interest period, and which can also be computed using this formula, the nominal interest rate divided by number of compounding per year. And we also have the n, which is equivalent to the total number of compounding. So so for this video, we will be discussing um, more on the compound interest and more examples related to compound interest. So interest to compute values of I and N. For example, we have the nominal interest rate of 12%. The number of years invested is 6 years. So this is just an example. This is how we solve for the compounded annually. If the interest is compounded annually, we have the I or the interest rate as 0.12 divided by 1, so which is just equivalent to 0.12. And for the number of years, we have 6 multiplied by 1, so that is 6. But when you say that it is compounded semi-annually, we have here the interest rate, which is 0.12. We need to divide it by 2 since we are solving the semi-annual, meaning to say 1 year is divided by 2. So we have 2 here, and that is equivalent to 0.06. And for the number of years, that is 6 times 2, so that is equivalent to 12. And for the compounded quarterly, 1 year is composed of 4 quarters, so that's why we have 4 here. And for the interest rate, we have 0.12 divided by 4, that is 0.03. And for the number of years, we have 6 years times 4, so that is 24. And for the compounded monthly, we have in 1 year, we have 12 months, so we have 0.12 divided by 12. That is equivalent to 0.01%. And for the number of years, that is 6 times 12 is equivalent to 72. So meaning to say, um, you'll be paying 72 times for the span of 6 years. We also have the compounded bi-monthly, which is 0.12 divided by 6, that is equivalent to 0.02, and n is equivalent to 6 times 6, that is equivalent to 36. So now we will be moving forward to the examples of compound interest. So again, you need to remember the formulas that we have for the compound interest so that we'll know how can we apply that to some problems. So now we also have the single payment compound amount factor, or F over P, that is equivalent to 1 plus I raised to N, and the single payment present worth, which is P over F, that is 1 plus I raised to negative N. We also have how we get the effective rate of interest, or the ER. So that is equivalent to the interest earned in 1 year all over principal during that year. So that is given by the formula F minus P all over P is equivalent to 1 plus I raised to N minus 1. And equivalent rates, we have if effective rate 1 is equivalent to effective rate number 2. So now let's have let's try some examples in solving compound interest. So example number 1, we have the amount of 20,000 was deposited in a bank earning an interest rate of 6.5% per annum. Determine the total amount at the end of 7 years if the principal and interest were not withdrawn during this period. So, in order for us to solve this one, we need to identify again what are the given points. So, the given we have here, the P is equivalent to 20,000. And we also have the interest rate, which is 6.5. So, that is equivalent to 0.06. I'm sorry, this is 0.65 because 6.5, and we need to divide that by 100. So that is our interest rate. And we also have the time, which is 7 years. So meaning to say 7 years is our N, and that is annually. So meaning to say this is R or I. From the formula that we have, this is I. So let's just write that as is so that we won't be confused. So we have the formula of the compound interest, which is equivalent to F is equivalent to P times 1 plus I raised to N, right? So we already know the P, we already know the I, and we already know the N. So what we're going to do is just plug that into our equation. So we have F is equivalent to 20,000 times 1 plus our I, which is 0.065. Since that is just compounded annually or per annum, so there's no need to divide that by any number. So we have 0.065 raised to n, which is 7. So if you try to calculate that one, that is equivalent to 31,079.73. That is in peso. So this is already the money that you'll get after 7 years if you have deposited 20,000 and is compounded annually by 6.5%. Okay, so we'll have next example, which is a man expects to receive 25,000 pesos in 8 years. How much is the money worth now considering interest at 8% compounded quarterly? So again, we'll have to identify the given. So again, we have here um, 25,000, which the man is expecting to receive after 8 years. So meaning to say 25,000 here is the future worth. It's not the present worth, since the man is expecting this 25,000 after 8 years. So F now is equivalent to 25,000, and the number of years is 8 years, and the interest, or the I, is equivalent to 0.08. And it is said that it is compounded quarterly. So meaning to say, should be divided by 4 and n should be multiplied by 4. So using the formula, F is equivalent to P times 1 plus I raised to n, we can find how much is that money worth now. Meaning to say, we need to find the value of the present worth. So plugging in the values that we have 25,000, that is equivalent to P multiplied by 1 plus our interest rate, which is 0.08 quarterly, and N, which is 8 times 4. So that is equivalent to P is equivalent to 25,000. Divide that by 1 plus 0.08 over 4 raised to 8 raised to 4 times 4. That is equivalent to 13,265.83 pesos. So, if the man is expecting 25,000 after 8 years, he needs to deposit 13,265 now so that he can get 25,000 in 8 years. So that is how we find the present worth. Next example we have here. How many years will 100,000 earn a compounded interest of 50,000 if interest is 9% compounded quarterly? So again, we have here 100,000. We have the compounded interest of $50,000, pesos. And if interest is 9%, and that is compounded quarterly. So how can we solve this problem? So what is asked here is to find the years or how many years that 100,000 can earn 50,000 in interest. So since the man or the person is expecting to have 150,000 pesos, that is 100,000 deposited, and that should earn 50,000 pesos. So meaning to say, the future worth now, we have the F now is equivalent to 150 pesos, 150,000 pesos, and the present worth, that is 100,000. And the I, or the interest, is 9% or 0.09. And since that is a compounded quarterly, so you need to divide that by 4. Now, what is asked from the problem is to find the years or how many years that the person can get 150,000. So, meaning to say our N here um, is the missing, or we need to find the n. So solving that, we have 150,000. Plugging that into our equation, we have also 100,000 multiplied by 1 plus our I, which is 0.09 over 4, and our n, which is unknown. So we have our n here. And since that is quarterly, we need to say we need to multiply that by 4. So we have 4 here. So I know you can already solve this one through shift solve. So if you try to solve that one, or if you try to calculate that, you'll get the value of n as 4.56 years. So that is how we solve for the number of years. Next problem we have here. A sum of 1,000 pesos is invested now and left for 8 years, at which time the principal is withdrawn. So we have here the deposited money is 1,000 and left for 8 years, at which time the principal is withdrawn. So meaning to say, after 8 years, the principal, or the 1,000, is withdrawn after 8 years. Now the interest has accrued is left for another 8 years. So only 1,000 is withdrawn from the earning, or from the savings, but the interest is still under the bank, or still left in the savings. So if the effective annual rate is 5%, that is annually again, effective annual rate is 5%, what will be the withdrawal amount at the end of 16th year? So how can we solve this kind of problem? Okay, so since we are discussing, or since we are talking about effective interest rate, and we know that effective rate, or we have here the ER, we've already discussed the formula of this one, which is equivalent to F minus P all over P is equivalent to 1 plus I raised to n minus 1. So we can use this formula because this is continuous. This is for the continuous formula. So F is unknown from here. Let's just write down what is given here. So we have P. is equivalent to 1,000 pesos. And then we have the interest or the I, which is equivalent to 5%, that is annual, so there's no need to divide that with any number. So we have 0.05. And then for the N, we have the 8 years for now. For the first one, we have the 8 years. So let's just try to solve this one first. So F minus 1,000 over 1,000 is equivalent to 1 plus 0.05, and it is invested for 8 years. So you have 8 minus 1. So the future worth of the money is already for 1,477.46 pesos. But it is said that after 8 years, the principal amount or the 1,000 is withdrawn from the savings. So meaning to say, we need to subtract our future worth by 1,000, since by this time we have already withdrawn the 1,000. So meaning to say, what is left from the money is already 477.46 pesos. So this is what is left from the savings or from the bank. So meaning to say, it is said here that the interest has accrued is left for another 8 years. So meaning to say, um, since the question or the problem is looking for the withdrawal amount after 16 years, so meaning to say this money now is our present or principal amount. So 1,000 is already off, so we'll just use this money as our principal amount. So we have F minus P, which is 477.46 all over 477.46 is equivalent to 1 plus 0.05, which is the interest, and another 8 years, because we've already done with the 8 years, so we have another 8 years minus 1. So now, meaning to say, the withdrawal amount is equivalent now to 705.49. So meaning to say, after 8 years or after another 8 years, the man or the person can still withdraw 705 pesos, 705.49 pesos. So that that is what the answer for the problem. Next is we have another example. We have here, how long will it take for the money to double itself if invested at 5% compounded annually? So we need to double, for the future worth, we need to double the amount that we have invested in currently. So meaning to say, let's say for example, we have invested 2, and we for the P, that is 2, and we need to find the future worth, meaning to say, since 2, and then for the future worth, that should be doubled, so meaning to say we have 4. And then we are looking for how long, so meaning to say N is unknown and I is equivalent to 0.05, since that is annually. So in order for us to solve this one, we can still use the same formula. So we have 4 as our future worth, 2 as our present worth, multiply that by 1, plus I, which is 0.05. So we are looking for the N. So N now is equivalent to 14.2 years. So this is now our final answer. So meaning to say, after 14.2 years, your money, which is 2, for example, will double, and that will become 4 after 14.2 years. Okay, last example we have here. If 5,000 shall accumulate for 10 years at 8% compounded quarterly, find the compound interest at the end of 10 years. So how can we find for the the interest after 10 years. So in order for us to solve this kind of problem, we just have to write down again what is given so that we'll know what is still missing or what do we need to solve for this problem. So again, we have 5,000 as our present money or principal amount. So we have P is equivalent to 5,000, and for 10 years, N is equivalent to 10 years, but it is compounded quarterly, so meaning to say multiplied by 4. And we also have the interest rate, which is 8%. That is divided by 4 because that is quarterly again. And we need to find the compounded interest at the end of 10 years. So meaning to say, what is our money after 10 years, at 10 years? So in order for us to solve this one, we have F is equivalent to P times 1 plus I raised to N. So P is 5,000 and 1 plus I. Our I is 0.08 divided by 4 raised to 40 as our N. So meaning to say we have F is equivalent to 11,000 40 pesos and 20 cents. But we are just looking for the compounded interest. We are not looking for the um, total future worth. Meaning to say, we need to subtract we have to subtract the capital that we have put or we have invested. So meaning to say that's minus 5,000 in order for us to get the total compounded interest after 10 years. So that will give us the equivalent of 6,040 pesos point 20 cents in peso. So that is how we solve for the compounded interest at the end of 10 years. So I hope you've learned something from this video. Those are all the discussions that we'll be discussing under compound interest. So we'll talk about continuous compound interest and discounts on the next session. Thank you very much and have a great day.